Hello students, welcome back. In this series of Principles of Agronomy, we have already covered introduction and agrometeorology part and the growth and reproduction, uh, growth and development, what are the factors affecting growth and development, all those concepts we have covered in gist. Today we are going to discuss about soil environment and its modification. So when we are talking about plant growth and development, suppose this is a plant, and when we are talking about its growth and development, there are several factors affecting its growth and development. The primary factor is one of the most important factor is the innate or inherent characteristics, or it is genetic potential of the crop or the variety of a particular crop. Okay, so if the variety is having higher productivity, high productive potential, then with optimum package of practice we can expect some higher profit or productivity from that particular variety. If a variety is having tolerance to biotic and abiotic stress, it will tolerate to biotic and abiotic stress. So depending on the variety or inherent characteristics of the particular biotype or the species, crop species, the productivity as well as profitability to farmers we can achieve. Then another factor is, one is internal factor, another one is external factor. In external factor we can call, one is climatic factor or the weather element, how they are affecting the, like in climatic factor as well, in aerial factor as well. Some abiotic factor we can expect, like weather elements like temperature, precipitation, relative humidity, how their wind speed, how they are affecting the crop growth. Then another one is biotic factor, like insect, birds, then pathogens, all these things, human being, how they are affecting the plant. So these are aerial factor. Then soil factor or edaphic factor, the soil phenomena that affect the crop production, that is called edaphic factor. So soil factor means the underground part of the plant, and it is most important because it supports the plant for its it gives anchorage or support to the plant. It provides nutrients, soil provides nutrient to the plant. It provides water to the plant, right? So plant takes water and nutrient from the soil only. So this is an important aspect, how soil is affecting the crop growth and development. In soil parameter we can say soil physical property like texture, structure, density, then porosity, compactness. Okay, so this is soil physical property, how, or physical characteristics, how they affect the plant growth and development. Another one is chemical properties like soil pH, EC, or electrical conductivity, pH, or acidity or salinity of the soil, then nutrient content of the soil, then or soil organic carbon, these, or CEC, cation exchange capacity, anion exchange capacity, how they are affecting the crop growth. Another one is soil biological property. So in three way we will study soil and its impact on crop. One is, another one is, last one is biological property. That means soil microbes present in the soil, they have significant role in nutrient dynamics, nutrient translocation, nutrient availability or mineralization, immobilization process. They are having several role, right? So how these physical, chemical and biological properties are affecting the crop growth, we will discuss in this particular lecture. Now the same thing we have already discussed, the crop environment, that is aerial environment or phylosphere environment, soil environment, or it is also known as rhizospheric environment or rhizosphere. Now soil fertility, when we're talking about soil fertility comes to our mind. Soil fertility means it is the inherent capacity of the soil to supply nutrient to plant in adequate amount and in suitable proportion. It's not like only adequate amount, if the nutrient is present in soil then that is a fertile soil. It should be in suitable proportion, it should have the capability or capacity to provide the nutrient in suitable proportion as well. But productivity, it is a capacity of soil to produce the crop with specific system management. All productive soil must be fertile, but fertile soil may or may not be productive. Why it is said so? Because if the soil is productive, that means it has the productive potential. But if suppose soil is fertile, it has the capacity to supply nutrient to the crop growth, but it is having some other constraint like water stagnation is there, drought condition is there, or water stress is there. Then you may say ki, there is like higher acidity, higher salinity is there. So in that case, if whether the nutrient is available plentifully or not, that doesn't matter, but some other constraints that hinders the growth and productivity. So in that case, the soil is fertile but it is not productive enough. So all productive soil must be fertile, but all fertile soil might not be productive. Okay. According to modern uses, soil fertility is the capacity to produce crop of economic value and to maintain health and soil without deterioration. Okay. So according to modern concept, soil fertility is the capacity to produce the crop having economic value or economical produce and to maintain the health of the soil without its deterioration. Fertility losses, how the soil fertility is lost. It might lose through the nutrient uptake by crop as well as weed, because crop and weed significantly take up huge quantity of nutrients. Then soil erosion, when the top fertile soil is eroded through different agents like wind and water, along with that eroded soil, some nutrients are also it is eroded. That means it is moved from that particular place. It is lost from that particular place. Okay. Then volatilization. These are the different losses of nitrogen like volatilization, denitrification, leaching. Okay, these are the nitrogen losses mechanisms. Then how we can maintain the soil fertility. So these are the factors how soil fertility is getting lost and how we can maintain the soil fertility. So for short term and temporary maintenance, you can use organic matter, green manure, fertilizer, biofertilizer, etc. For long term maintenance, you have to reclaim the soil by amendments and ameliorants. Then soil conservation practices we have to follow to prevent the erosion losses, because through erosion so many nutrients and so much quantity of nutrient are getting lost. Next, let's discuss about soil physical environment and how it is affecting the crop growth. So under soil physical environment, there are some parameters like soil texture, structure, aeration, water, mechanical resistance, depth of the soil. They have significant impact on crop growth and development. Basically, they have significant impact on root growth and root development, because most of the part of the root is under soil. Now, soil texture. Soil texture, what is soil texture? It is the relative proportion of sand, silt and clay. So, how much percentage of sand, silt and clay present in a soil, that indicates soil texture. So, there are 12 textural triangle that was proposed by USDA, US Department of Agriculture. Textural triangle, there are total 12 textural triangle are there. Now, if we say silty soil, that means more than or equal to 80% silt fraction is there in the soil. If we say sandy soil that contains more than 80 to 85% of sand. Clay soil that contains more than 35 to 40% of the clay. Then we can call it as clay soil. Now, soil texture is a permanent feature of soil. It is hardly it is possible to modify the soil texture. Soil texture is a permanent feature. Soil texture influence water holding capacity, nutrient retention, drainage, strength of the soil, compressibility of the soil, thermal regime of the soil. So how it contributes the water holding capacity and nutrient holding capacity. So as the soil texture is finer, it can retain the nutrient as well as water for longer period. Okay. Then again, compressibility, it is higher in fine texture soil, it is less in sandy texture soil or coarse texture soil. Now, soil texture, what are the fractions? Like in soil, there are different fractions. Like clay fraction, it is mostly asked in the competitive exam. If the diameter of the soil is less than 0.002 millimeter, then that is clay. Then silt 0.02 to 0.002 millimeter, fine sand 0.02 to 0.2 millimeter, coarse sand 0.2 to 2 millimeter, fine earth less than 2 millimeter, gravel 2 to 20 millimeter, and stone more than 20 millimeter in diameter. Then this is the soil textural classification. Now heavy texture soil, that means it is not like if when we are saying heavy texture or light texture, it is heavy and light in terms of weight, but it is heavy in terms of workability. It is having hindrance, or when we work we cannot work properly. That is heavy texture soil. Light texture soil, it is easier to work through. Okay. So heavy texture soil are suitable for rice, cotton, sorghum, coriander. These crops we can easily grow in heavy texture soil or black soil or clay soil. Then light texture soil, it is suitable for groundnut, potato, tobacco, pearl millet, legume, fodder, etc. Okay, these crops are being easily grown in light texture soil or conveniently grown in light texture soil. Next physical parameter is soil structure. What is soil structure? So arrangement of primary particles in and their aggregation. Arrangement of primary particles means this sand, silt, clay, how they are being arranged in a soil, and their aggregation. When they form aggregate, how they looks like. That is soil structure. Okay. So soil structure can be easily manipulated by tillage practices. So flocculation or flocculated soil means well aggregated soil, and flocculation is done by like some minerals like calcium and magnesium, uh, and and sesquioxide also plays a greater role in flocculation. Okay, a deflocculation or dispersion, that means disintegration of soil structure, that is mainly caused by sodium. If there is dominance of sodium ion, then there is dispersion or denaturation or deflocculation of soil. That means soil aggregate breaks down. Okay, now aggregate, when we are talking about aggregate, natural aggregates are known as fragments and artificial aggregates are known as clod. Aggregates, when the aggregate size is more than 250 micrometer, then that is called macro aggregate. When it is less than 250 micrometer, then that is called micro aggregate. Okay, so micro aggregate less than 250 micrometer and macro aggregate more than 250 micrometer in diameter of the aggregate. Now soil structure are of four different types. Okay, so basically a platy, when it is like more horizontal in nature and it hinders infiltration. It occurs in recently deposited clay soil. Okay, prismatic or columnar, it is like, suppose platy is like this. Okay, prismatic or columnar is like this type of structure. So it is mainly found in B horizon of clay soil. Then blocky, like it is like uh, block like structure. Okay, so blocky, it is mostly found in upper part of B horizon. Then granular and crumby, they are basically the single grain structure, and crumby, it is having porous in nature. Okay, granular is not that much porous, but crumby is porous in nature, and crumby is most suitable or most ideal soil structure for agriculture activity. Now, water stable aggregates are more necessary for good physical condition in soil for longer periods. So, when there is less water stable aggregates, what happens? It is more prone to erosion. Okay, so basically, it can easily be broken down by water or rainfall or water flow, okay, water movement. So, mostly water stable aggregates are desired. Then improvement in stability of the aggregate. How we can improve the stability of the aggregate? Growing suitable crops like leguminous crop are mostly adopted. Adopting suitable cropping system, so crop rotation, then crop rotation with leguminous crop, intercropping with leguminous crop, that is also recommended. Then applying crop residue in the soil and adding organic matter like FYM vermicompost, we can improve the stability of the aggregates. Next physical property of the soil is soil water. Okay, soil water. So how soil holds the water? It is due to adhesion and cohesion. Adhesion means attraction between two different type of particles or dissimilar particles. Like soil, when it attracts the water, then that is called adhesion. Cohesion means the attraction between similar particle or among similar particles. When water and water, they attract each other, then that is called cohesion. So in the soil, water movement happens due to both cohesion and adhesion. Water potential in soil is always negative because we have to apply some pressure. When soil holds water, we have to apply some pressure to remove it. That's why it is always negative. And in saturated soil, it is zero and it is the highest. Okay, soil water moves from, always remember, soil water moves from higher potential to lower potential. Available water range, that is when the water potential of the soil water potential is between minus 0.33 bar to minus 15 bar, that is called available water. Okay, minus 0.33 bar means it is at field capacity. Okay, in water management class we will discuss all these things. Minus 15 bar means it is at permanent wilting point. So between field capacity and permanent wilting point, there is available water. Soil water, if it is more, then soil strength is less. Okay, soil strength is less, the soil temperature will be moderate, the nutrient availability and mobility will be higher because when the soil is dry, the root cannot trap the nutrient, because nutrients are mostly available in ionic form, and if there is no water in the soil, then that nutrient is not available in the ionic form, and the plant cannot take up that nutrient, right? Then mineralization will be higher, then biological activity will be higher if there is proper soil moisture, and soil moisture is controlled by rainfall, irrigation as well as drainage. Okay, now next, soil physical property is soil temperature. Soil temperature, it is partly used partly used to increase soil temperature. Okay, uh, when soil temperature is higher, there is evaporation rate is higher, so specific heat of soil is increases with the soil moisture, because see, water has the specific heat. Let me tell you first what specific heat is. Specific heat is the calorie of energy that is required to increase 1 gram substance, into 1 degree Celsius. Okay, to increase 1 gram substance to 1 degree Celsius, that is called specific heat. So specific heat of water is generally 1 calorie per gram per degree centigrade, but specific heat of soil is 0.2 calorie per gram per degree centigrade. So when there is a dry soil and wet soil, to increase 1 degree Celsius of 1 gram dry soil and wet soil, it is more, there is more specific heat is required or more calories required in wet soil. Okay, specific heat we have already discussed, it is in unit calorie per gram per degree centigrade, and water it is 1 calorie per gram per degree centigrade, and of soil it is 0.2 calorie per gram per degree centigrade, and for organic matter it is 0.5 calorie per gram per degree centigrade. Now, thermal conductivity, it is inversely proportional to porosity and it is directly proportional to water content. So, if the water content is higher, then thermal conductivity will be higher. If the porosity will be higher, then the thermal conductivity will be less. So, tillage increases porosity, it reduces thermal conductivity and it increases soil temperature. Latent heat of vaporization of water, that is 580 calorie. Okay, latent heat of vaporization of water, that is 580 calorie. Optimum soil temperature for germination of winter cereal, that is 15 to 18 degrees Celsius. For maize it is 32 degrees Celsius. For sorghum, sugarcane, cotton it is 30 degrees Celsius, and for mustard 18 to 23 degrees Celsius. Optimum temperature of microbial activity, there is no activity of microbes at less than 5 degrees Celsius and more than 50 degrees Celsius. So optimum is 25 to 35 degrees Celsius for microbial activity in the soil. Control of soil temperature by waterlogging, mulching, tillage, by adding organic matter, we can control the soil temperature. Now next important physical parameter, that is soil air. Okay, so soil air like atmosphere aeration or soil aeration is also required, because a root is mainly confined to soil, and if the soil aeration is not proper, root cannot respire properly. Through respiration, as we have already discussed, we get energy. So if the root cannot respire properly, then the energy for metabolic activity will not be proper, so root can be degenerate. Okay, it will not act properly, it will not uptake the nutrient and water properly. Now, soil air volume ratio of soil solid, water and air changes due to wetting and drying, swelling and shrinkage, tillage and compaction, and aggregation and dispersion. So these are the factors through by which there is change of volume to soil solid ratio, air to soil solid ratio. Movement influenced by movement of soil air is influenced by temperature, water diffusion, and pressure. Influence on crop growth, how the soil air influence crop growth. So basically, if the soil oxygen level is less than 2%, then crop growth stops. Okay, and the optimum is around 10%. Total pore space, in case of sandy soil, the total pore space is 20 to 30%, and there are nearly 25,000 pores per meter square in case of sandy soil. For loamy soil, it is the pore space is around 30 to 50%. For clay soil, it is 50 to 60%, and there are 25 million pores per meter square of clay soil. Next, water table is called, it is shallow. Water table is shallow during rainy season. So because in rainy season, the water table is nearer to the ground, so it is considered shallow in the rainy season. And water table is deeper in case of summer season. In soil layer there are different in soil profile there are different zone like O horizon, A horizon, B horizon, E horizon, C horizon, R horizon are there. So A and B horizon in together in total it is called soil or true soil. A plus B plus C horizon it is called regolith. Okay, it is the unconsolidated parent material um, above the parent material. Next one is soil strength. So it affects the root growth. Soil strength is measured by core penetrometer. It depends on the soil moisture, bulk density and compactness. Next one is soil color. It depends on parent material, organic matter, mineral, water status of the soil. So we have in this particular lecture we have discussed about soil physical property and how it is affecting the crop growth. In the next lecture we will discuss about soil chemical environment and how it is impacting the crop growth. Okay, so till then if any doubt you are facing at any point of time you can let me know in the comment section so that I can put a separate lecture on that particular concept for thorough understanding. So see you in the next lecture. Till then, have a great day. Bye bye.